In this video, we're going to be discussing how to solve this advanced problem on functions and polynomials. So here's the problem statement. Let p of x, as a function, be defined as x squared plus 8x plus 12, and q of x be defined as x cubed plus 5x squared minus 6x. Define r of x, a third function, as p of x times q of x. Find all values of x for which r of x equals 0. So this is an Algebra 1 problem where we're going to need to use a variety of different techniques to solve this problem. So we have three different main elements here. We've got quadratic equations. This x squared plus 8x plus 12 is a quadratic equation. We've also got functions. All three of these things are functions, basic functions here. And we've got polynomials. Q of x, x cubed plus 5x squared minus 6x. This is a polynomial in degree 3. A polynomial is basically just like any other expression, except it might have multiple x cubed or x squared terms, and it's a little bit harder to factor and figure out than a quadratic equation. So to solve this problem, we're going to need to use many different approaches to get to the answer. So they want to know all values of x for which r of x equals 0. So that tells us in this product, either p of x, q of x, or both need to be 0. So that's a lot of information right there. Either or both of them have to be 0 because anything times 0 is going to be 0. So we need to find out which values of x make that happen. So we can start off by simply solving this quadratic equation because we're trying to find out the values of x when input to p that result in 0 because that will make the entire p of x 0 and thus satisfy the question. So we essentially have a complete quadratic equation in one variable here. It's the x squared plus 8x plus 12 equals 0. So this is a pretty easy monic quadratic equation. So all we have to do is factor this. This factors into two portions as usual, as x plus 2 times x plus 6. Because we've got a product of 12 and a sum of 8. 6 plus 2, 8, and 6 times 2, 12. So that tells us our two solutions are x equals negative 2 and x equals negative 6. Okay, so that solves the first quadratic equation. So next, we have the second one, which is not even a quadratic equation, it's the polynomial, the q of x. So we also want the q of x to be equal to 0. And in order to do this, we also need this entire thing with the value of x and makes it 0. So while we can't use the same factoring technique on a polynomial because of that x cubed term there, we do have an important trick we can use here. You'll notice the common factor of x. There's an x here, and an x there. On all the terms, we have an x, and this allows for a very useful factorization. We can factor out that x, and essentially have x times x squared, because we're taking out the x term, x squared times x, back to x cubed again. So x times x squared, and then plus 5x, because we're taking out that 1x and made it squared, then minus 6. And all of this is the factorization. So you can see we've come up with a quite interesting result here. This is a quadratic equation that we know how to solve. So we just applied the normal factoring technique for this, getting the factors of x plus 6 and x minus 1. Because we've got the 6 times negative 1 is negative 6, and 6 plus negative 1 is 5. So we successfully factored this second polynomial here. And all we have to do now is find the values of x and make it equal to 0. That's pretty easy. X equals negative 6 and x equals 1. So we found all values of x that make both of these equations equal to 0. We already have negative 6 here. There's also a separate value of x that you might not see that's applied if you look at this outer x here, not just the inner quadratic. If you multiply this entire thing by 0, of course you're going to get a product of 0. So when this outer x is equal to 0, then the entire thing is also 0. So we've got negative 6, negative 2, 1, and 0. Go ahead and write these down here as our final answers to this problem. So essentially what we had to do there is combine the quadratic equation factoring techniques and some factoring of polynomials in order to get to the answers we needed, because essentially we needed to find the values of x that made one or both of these p of x terms equal to 0. And to do that, we had to apply the quadratic equation factoring technique and the polynomial factoring technique. So that's how you would solve a problem like that on polynomials, functions, and quadratic equations in Algebra 1.